Okay, so a really common task is graphing points, uh, finding solutions to equations, things like that, finding x and y intercepts, finding the slope of a line, um, and that's what I'm going to cover here, um, hopefully in less than 10 minutes. So the find the x and y intercept of the line are basically kind of going back to my axes here. So I have axes drawn perfectly straight. There we go. So I have my x-axis. Remember, the x-axis is the horizontal axis, and the y-axis is the vertical axis. And so finding x and y intercepts, basically an x-intercept, we usually talk about the x-intercept of a function or of a graph. And the x-intercept is the place where this graph crosses the x-axis. There are some graphs that have multiple x-intercepts, but where does it cross? So it crosses the x-axis. We call that the x-intercept. Now, one of the things that's common of every point on the x-axis, this point, and this point, and this point, and this point, and these points over here, what they all have in common, well, this looks like it's maybe 5 comma 0. I'm just kind of ignoring the grid lines on there. Maybe this is 3 comma 0. Remember, ordered pair, the first number tells us how far to go across. The second number tells us how far to go vertically. Maybe this is 2 comma 0. Again, the actual numbers aren't that important. What do all of these have in common? What about over here? This is negative 2 comma 0 and negative 5 comma 0. What do all of the points that are on the x-axis have in common? It's that. Y is 0. 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 So using that as our starting point here, I know any point that's on the x-axis has a y coordinate of 0. That gives us the strategy to plug in y equals 0 into our equation. So I'm going to go ahead and show you how to do that. It's pretty quick and easy. Let's take this first equation here. Negative 2x plus 3y equals negative 12. So I'm gonna rewrite it over here. Negative 2x plus 3y equals negative 12. So I'm going to plug in 0 for y. I'll substitute in 0 in place of y and rewrite it, and then I'll solve for x. So find out what the x value is that makes my y coordinate equal 0. It's a good strategy for doing this. So I'm going to have negative 2 times x. I don't know what x is, plus 3 times 0. So in place of y, I'm putting 0 equals negative 12. What's 3 times 0? 3 times 0 is 0. So negative 2x plus 0 is just negative 2x. The really nice thing about this is it kind of speeds things up. Plugging in 0 is really nice when you're doing the math there. So let me complete this algebra here. Negative 2 times x equals negative 12. I can kind of do this in my head. Negative 2 times some number equals negative 12. I know the number's got to be 6, but the algebra step would be to divide both sides. Since negative 2 is being multiplied times x, I need to undo that. I'll divide by negative 2. And since I'm dividing the left side by negative 2, to keep things balanced, I'll divide the right side by negative 2. And then I'll get negative 2 times x divided by negative 2. The negative 2's cancel. Or, I mean, it's better to say negative 2 over negative 2 is 1. So this is 1x. But we all use the word cancel. Even teachers use the word cancel. So x equals negative 12 divided by negative 2. And that does a negative divided by a negative will become a positive result. And 12 divided by 2 is 6. So it is what I thought. Okay, so here's what I know. When I plug in 0 for y, x is 6. That is one solution to this equation. When x is 6, y is 0. I can graph that. 1, 2, 3, 4, 5, 6. There we go, 6. So one point on this graph is going to be 6 comma 0. 6 comma 0. That is one solution to this equation. A solution to an equation is a point. It could be like You could have lots of portions of the, or maybe the point is just has just one value, right? But a solution is a point that makes the equation true. And 6 comma 0, if I plugged it in, let's check. We plug in 6 for x, negative 2 times 6 plus 3 times 0. Does that equal negative 12? Yeah, it does. It equals negative 12. So yes, it's a solution. Is it the only solution? No. There's tons of solutions. There's an infinite number of solutions to this. But one of the solutions, super convenient to find, is let's plug in 0 for y, because the math becomes really easy. Well, if we can plug in 0 for y, we can also plug in 0 for x. So let's take the same equation, negative 2x plus 3y equals negative 12. And I'm going to plug in 0 for x. So 0 for x. And then I want to know what value of y makes, do I get when x is 0? So actually, when I'm doing this like on paper, what I'll do a lot of times is I'll cover up the variable that I'm plugging in 0 for, right? I'm going to plug in 0, negative 2 times 0, 0. I can just kind of like ignore it. I'll cover it up with my finger or with my hand if I'm doing it on the whiteboard. Okay, so 0 plus 3y is just 3y. So I can just cover it up. I could have done the same thing over here. Let me cover up 3y, and then I get negative 2x equals negative 12. I get x equals 6. Same idea, really quick to do because I'm plugging in 0. It's a good choice. If you can plug in 0, if you can make zeros, make zeros. So I'm going to divide both sides by positive 3, because 3 times y divided by 3, I can do 3 divided by 3 is 1. I get 1y. Now, we normally don't do that. We just say, oh, let's just cancel. Okay, but what you're doing is replacing the 3 over 3 with 1 times y. So I divided this side, the left side by 3, and I need to divide the right side by 3. So I get y equals negative 4. So another solution, there's lots of solutions, but another solution, perhaps the easiest other solution to find was 0, negative 4. Okay, so 1, 2, 3, 4. I'm going down in the y direction, down to here. Negative 4, 0, negative 4 is another solution. So now my line, there's a couple of reasons why I know this is a line, but you look at the exponents is usually the first thing that you look at. But this line passes through 0, negative 4, and also passes through 6, 0. So this is the graph of all of the points. So this point makes the equation true. If I plug in this point, it makes the equation true. If I plug in this point and this point, every point on this line, if I plug it in, it makes the equation true. And there's no way I can draw every single point. I can't draw. There's an infinite number of points that work. There truly are. So we use that line to represent all of the points that make the equation true. So that's the graph of the line. The x and y intercepts, we would say the x-intercept was 6, and I could say x equals 6 or just 6, or I could say 6 comma 0, can be expressed all the way. The y-intercept of line A is 0 comma negative 4, or just negative 4. The slope is typically called rise over run, and I'm going to handle that in another video.